Okay, guys, so I got a request to do one from worksheet 11-5, 31A and B. So it wants to know, it wants you first to determine the cell potential and the cell potential under standard of the stated conditions for the electrochemical reaction described here. State whether it is spontaneous or non-spontaneous under each set of conditions at 298.15 Kelvin. So I went to the appendix in your book and I looked up the half reactions. And so starting with A, we have Hg liquid going to Hg2 plus, and that's solid. So if I look at this, I know that mercury has to be changing oxidation states, and so does silver because I see them as elements. If they are elements, then they must be oxidized or reduced. So this one has given up 2 electrons, so this is plus 2 electrons. So this would be loss of electrons, oxidation. So I know I'm going to have to flip the E naught for this cell. And my other half reaction is going to be Ag plus going to Ag solid. And they've already balanced it for us. There's 2 here, and so that would be 2 electrons. And so when I look up the cell potential for Hg, I see it's that Hg2 plus is going to Hg, and my 2 electrons are over here, but I need them on the other side. So I'm going to take that cell potential I found and I'm going to flip it over. So for this one, the cell potential is going to be 0.851, but I'm going to have to make it negative because it's oxidation, not reduction, as listed in the table. So I looked up silver, going to silver metal, and that value was 0.222 volts Chardonnay. And when I add those two up, yes, I'm going to use my calculator. I do know that it's going to be negative because I'm quick, but negative negative 0.851 plus 0.222 equals, and that's negative 0.69 or 29 volts. So going back to the question, it says state whether it's spontaneous. No, it is not spontaneous under the conditions written. So this one will be no. B, the galvanic cell from the half reaction of aluminum electrode. So they're just telling us what we have: aluminum electrode and aluminum 3 plus. And then we have nickel electrode, and we have nickel 2 plus. So I don't know which one's oxidation reduction, but it did tell me it's a galvanic cell. So I'm going to have to make this a positive reduction or a positive reaction. And so if I look up the values, and I've written these backwards, so let me rewrite them. If it goes from aluminum 3 plus to aluminum plus 3 electrons, right? No, wait, plus 3 electrons over here. And nickel 2 plus 2 electrons gives me an I. And if I looked those values up earlier as well, and aluminum is negative 0 or negative 2.07. And this one's negative 0.257. So I know it's galvanic, so I have to get a positive cell potential. So I'm going to have to take this reaction and flip it to oxidation. So aluminum plus goes to aluminum 3 plus 3 electrons, and I get positive 2.07. And then I have Ni2 plus 2 electrons yields Ni, and that's negative 0.257. Sorry about the dog. And if I do that math, I get 2.07 minus 0.257. I get positive 1.813 volts. And so, yes, it is spontaneous. So, and you notice I didn't balance the equations or the electrons, because even if I balance them, it has no effect on the voltage. And so I don't have to worry about balancing them. But if I wanted to, I'd have to multiply here by 2 and here by 3 to get 6. So 3 and 3. And that would balance my equation. Okay, I hope this is helpful. And before the dog goes ballistic, I'm going to let you go. Bye.